Okay, today is 8.2, graphing inverse variations. Goal is to identify asymptotes when we're graphing those inverse variations and using the graphs of the inverse. We're actually going to spend more time on the first goal there. On your calculator, your graphing calculator, I want you to plug in y sub 1, y equals 1 over x, and in y sub 2, y equals negative 1 over x. Okay? You can do a quick sketch to describe your graph, and then we're going to answer these two questions. We'll actually define branches and asymptotes using those pictures. If you do that now, please, if you need a graphing calculator, bring something of value over to the desk, and I will exchange it for a calculator. Here we go. On this first one, well, if you graph them both at the same time, that's what I end up with now. I've got the light shining on it, but looks like a pretty cool star. Maybe it's the brightness of the star that's probably the light.
More the brightness of our futures, Mr. McCoy.
Well, I think so, yes. Okay, so I'm going to turn off the second one here and then hit graph. And you'll notice on this graph, you get this deal where the graph takes off from negative 10 and then it starts cruising downward, and then all of a sudden it jumps up here and starts cruising downward. Okay? These thingamabobbers here, we call those thingamabobbers branches. That way we don't have to call them thingamabobbers. Okay? Those are called branches. All right? And those branches are approaching these things called asymptotes. Okay? Now be careful when you say it. Asymptotes. Okay? This thing right here at x equals 0 is called an asymptote. Notice x equals 0 runs this way. It's actually the y-axis. That's an asymptote. This graph is getting infinitely close to x equals 0 until it all of a sudden jumps way up here. And then it's getting farther away from x equals 0. Okay? The graph is running really close to the line y equals 0. That's also an asymptote here. That's your horizontal asymptote at y equals 0. Okay, notice that's the x-axis. This graph is really close and it starts moving away, and all of a sudden it jumps up here and it gets infinitely close to y equals 0 again. It never hits y equals 0 in this graph, and it never hits x equals 0. Okay? Branches and then asymptotes that we can't see. Now, there is a way on the mode of your calculator to actually do somewhere where it says connected. I don't want to spend a lot of time on it, but I don't know where it is on this one. I don't see it. So I'm not too worried about it. But there is a way to actually see the asymptote. I know you can see them on some of the other ones, but I'm not worried about that. On our graphs, we're going to show the asymptotes as dashed lines. Okay? They're invisible lines that we can't see that our graph approaches. Okay? Now let's talk about why they approach those asymptotes. Why could our graph never actually reach 0 on x? In other words, why could this never be 0 for x? Nick?
Because you're always dividing by 1. Divided by x.
Yeah, you're dividing by x, and yeah?
You did divide by 0 error if x is 0.
Good. You can't divide by 0. You get an error. Anytime you divide by 0, you get an error. In fact, if you hit your table function of your calculator, you'd see in the calculator actually says error. Dude, error. I can't divide by 0. That's an error. All right? So, we have an error. Can't divide by 0. Okay. Why could y never be that? Yeah?
Because when you divide by something, you never get 0. It would get infinitely smaller, but it would never actually be 0 because that would imply that nothing was there.
Well, that's really good, yeah. Man, when you divide by something, you can't get 0. You just get infinitely close to 0. You can't actually get 0. I can't even say it that good, Jordan. Well done. That's awesome. Okay. Very good. Any questions there? That's why those are asymptotes. Okay, now we're going to identify the asymptotes in a different way. So let's take a look at and talk about translations of the graphs. Okay, Jaden, you need those 3. Okay. All right, so on the translations of the graphs, you don't have to read about it right now. If you want to later, just for some fun reading before, probably when you wake up in the morning, get you pumped up. Probably wouldn't put you to sleep. You get too hyped up right before bed, so don't read it before bedtime. Okay, what would horizontal and vertical asymptotes be for the following equations? Well, remember our horizontal asymptote is a line that we get infinitely close to. And the way we find these asymptotes, we actually do HK shifts. So if you remember our old friend HK, HK was, we dealt with vertices when we did parabolas, vertices when we did with absolute value. Okay, we've talked about HK shifts with our exponential functions. Well, HK shifts here shifts our asymptote. Okay, so H is always coupled with X, and K is always coupled with Y. K is generally our constant number. It's the thing that at the very end we add to. It's in everything we've studied, K has always been our constant. It stays the same here. Okay, X is always, or H is always in parentheses with X in some way. Now the deal is with this group, we don't actually see parentheses. However, where would X show up in one of these problems? It would show up in the denominator. Why? Because there's implied parentheses in the denominator. Okay, so our H value for here is actually what?
Minus 0.
Yeah, it's minus 0. It's nothing. X is 0. H in this one's 0. What's K?
0.
Yeah, well, K is what we're adding the constant at the end. So in this case, it's plus 0. K is 0. So our asymptotes are actually at 0 and 0. Now, usually we wouldn't really show a vertice here, like an ordered pair, but we would say this is our X asymptote, and this is our Y asymptote. Hey. Yeah, it's in the bottom tray there. Okay. And so what's it here?
H equals 0, K equals
0. H equals 0, K equals
7.
7. So that means X equals 0, Y equals 7. What that means when we're putting into a picture like this, we have our XY axis. Our H is here. Now we don't really see it. I'm trying to dash it a bit. Zoom in there. Our H is there, and then our K is at 7. So if this was 7 here, we would have another asymptote. We're going to see that when we graph these here in a minute. Okay, so it's almost like you've moved your XY axis upward. It's like you're moving the crosshairs up. Okay? Go ahead and finish up these last two. What are the H and K values? Okay, here H equals
2.
2. It's whatever makes this 0, right? Okay, K equals
7.
7. Remember, this is X, this is Y. Okay, here H equals
-2.
-2, and K equals
-7.
-7. This is X, this is Y. Any questions there? Have them rate themselves 1 to 5. Get HK? All right, you guys are looking like you're ready to move on. Here we go. On the back of the graphs, one of the graph pages I gave you steps for graphing these equations. Now, these are just guidelines. You don't have to do these. Okay? But A, identify the asymptotes. B, design a table of values, identifying the asymptotes. C, find values for 2x values greater than. So this is the one we may change up a bit. Okay? Where we actually, sometimes it's nice to do it this way using these two guidelines. Sometimes we'll do it the other way, and I'll show you that here in a minute. Find x and y intercepts if you haven't already found them. Find a large x value like 10 or a large negative x value like -10, and draw asymptotes and plot your points. Okay, so if you need guidelines, there you go. Okay, we're going to work through some together. So on your assignment, number 3 on the example side, okay, so you're going to have your piece of graph paper next to you that has your table and your graph. And then you're going to want to write down number 3 next to it. And we're going to go through and sketch the graph and identify the asymptotes. Yep. Well, look at the other piece you got. No other side? I didn't give you guys enough. Huh?
Okay.
Did I not give you guys the other piece? Let me find it.
You said donde está and everything.
It's okay, I can't help you quite right now.
I thought you said donde. You did.
I don't.
Donde is where are you going?
Isn't there one that had like multiple tables?
Say donde for where.
Oh, only 4 on one. Okay, you should have 8 total graphs. Okay, right?
1, 2, 3, 4.
It's on the back of this.
Yeah, you got to find it on the back of your.
It's on the back of this one.
Yeah, your graphing inverse. Okay. Go grab your other paper. Okay, if you didn't grab all the papers you need. They're on the on the card up there. Okay, here we go. So y equals 2 over x, all plus 1. We're going to put that into our table. Okay, we're going to identify our asymptotes. Everyone label what your x and y asymptotes are. X equals and y equals. Yes? All right, so what's our x asymptote? 0. Y asymptote? 1. Now I will tell you, you should really learn to do these without your graphing calculator. All of you that want to just throw them into your table. It will help you on your quiz and test. That'll be a hint to you.
Are we going to have not graphing?
I don't know. But it'll help you on your quiz and test. I probably do know. All right. So our x asymptote, is that our vertical or horizontal?
Vertical.
Horizontal because the x.
Okay, let's see. X equals 0. That's this line right here. It's where x equals 0. Is that vertical or horizontal?
Vertical.
That is a vertical asymptote. So when x is 0, y is what? No. Y is undefined, right? You can't have it. It's undefined. It's an error. That's how come you have an asymptote there. It's a discontinuity is what we call it later on, but it's an asymptote. It's something that we cannot actually continue our graph from there anymore. We will have to lift our pencil to continue graphing. I know, it's crazy. Okay, so what I'm going to do is I'm going to explain that I hope I'm going to get it across that as I'm filling out this table, there's a bunch of different guidelines you could do, and Mr. Vogel will teach it a bit differently than I do. But what I do here, yeah. But this part's undefined. So you'd have undefined plus 1. If you plug in 0 for x, that part would be you'd have an undefined piece plus 1. So you'd have still the whole thing undefined. You can't if I say here's something and you don't know what it is at all, it's just something that doesn't exist, and you're going to add 1 to it. What do you end up with? And that kind of makes your mind spin around a bit. So that means it's undefined. The whole piece is undefined. Okay, I know what you're saying though with the plus 1. Okay, our plus 1 is going to be a constant all the way through this. No matter what we do at the end of our fraction, we're going to have plus 1. And even in the undefined piece, there'll still be a plus 1. It's just we have an undefined plus 1. Okay? So, right here, I have 2 over x. So I'm just going to focus in on the y equals 2 over x. Now, those of you talking and not paying attention right now, this is where you're going to get lost. We studied that yesterday. Everyone remember that?
Yeah.
How did you end up with 2?
You found constant.
Yeah, you multiplied y times x. Okay, and actually let me write it over here. You did x times y to get our constant of 2. Everyone agrees there?
Yeah.
Okay, well let's find that piece right here. What things multiply to make 2?
1 times 2.
Let's start with like negatives first. Negative 2 and negative 1. Okay. Anything else? Negative 1, negative 2. Dude. Some advanced math here. Okay, what else? 1 and 2. All right. Crazy. What else?
2 and 1.
2 and 1. Man. All right. What if I said like 4? 1/2. Whoa, we're getting really crazy. Okay. Everyone with me there? Was that terribly difficult?
Yes, sir.
Yes?
No.
No. Okay, so here's what we've got. I know when x is -2. Okay? When x is -2, this piece is going to give me what? Well, when I put -2 in, what do I get? I get that -1, right? -1 plus 1 is? 0. You guys with me? Okay. Oh, I messed up my order. I should have put that's okay. All right, some of you are going to get really frustrated here because I'm going to put -1 here, and you're like, no, it's like the wrong order. Okay, that's okay. Okay, when I put -1 in for x, what does this give me right here?
-2.
Gives me that -2, -1 times -2. So I'm trying to make the relationship that really whatever we have here is the same piece that's going right here. So that -1, -2, that's what we got. You guys with me? Okay, so if I have 1 here, what am I going to have here? 2, because 2 divided by 1 is 2, and we did it there. If I have 2 here, what do I get here? 1. Okay, and we keep doing this, and we could put 4 here, and we get what here? 1/2. Right? Because 2 divided by 4 is 1/2. Okay, and then we could put -4 here. What would we get here? Uh-oh. -1/2, because -4 times -1/2 is 2. Right? How many are with me? Okay. -1/2 plus 1 is? Yes, 1/2. Here?
-1.
Here?
3. 2. 3/2.
Okay, we have an ordered pair, -4, 1/2. We have another ordered pair, -1, -1. We have another ordered pair, -2, 0. Another one, 1, 3. 2, 2. 4, 1.5. Yeah, Mano. Yes?
Do you have to do that as well as 2 every time?
Did it help you build your table?
Yeah.
Then I would. Okay? If it helps you build your table, I would. Now, I will tell you that's where Vogel and I will differ on this. He goes straight off what was on the back of the page that you're using, where you try to make, the other route is trying to make your bottom number equal that number, your bottom number equal 1, okay, which works really well for this problem. But as we progress, it gets a little tougher. And I was teaching it all that way too until I was talking to another math teacher that like, this is a great route, and I thought it was pretty good. So anyway, we'll kind of we'll talk about that as we go too. Let's put in our asymptotes. We're going to put in our y equals 1. That's our vertical or horizontal asymptote. Toki, what's up, man? Oh, grab the test. It's in the bottom tray on my desk. Okay, let's put these points in. -4, 1/2. Boom. See it down there? It should say Toki on it. We have -1, -1. Unbelievable. We have -2. We have, oops, -2. That's 0. Find it, Toki? You didn't say the one that says Toki on it? Oh, maybe it's over here then. It's not in there. All right, Toki.
You lost this test.
No, I didn't lose the test. Okay, finish graphing that, please. Here we go. So you got this branch, hopefully. So we're going to extend that and make sure it curves so that it runs parallel to those asymptotes there.
That's pretty cool.
That is pretty cool.
Pretty branch.
Okay, and let's go ahead and we got to get this bar. So 1, 3, 2, 2. That's a cool one. And 4, 1.5. Okay, and it's going to approach the asymptote. We know that. Booyah style and Kirchhoff. There we go. Yes? Yes, you're allowed to go past the dots on this. Yes. I want you to continue past the dots on these. To run it. And, okay, we're going to assume you know it's getting infinitely close to the asymptote there. Yep. Good question. Okay, how many think you can graph one? Okay, let's try the number 4. Okay? Number 4, let's go ahead and start by identifying your asymptotes. What's that? Word.
Are you really?
I don't think he is.
I'm speaking Spanish.
Okay, x asymptote is, everyone?
3.
Y asymptote?
1.
1. Good. Just put it in the inbox. Yeah. Okay, so I'm gonna go ahead and put those on right now. So x equals 3 is right here. So we've got our dashed line like that. Okay, so our graph is going to shift to the right 3, and it's going to shift up 1. Totally radical, but not really because it doesn't have a radical symbol. But we'll let it be in the radical family just because we want it to be. Okay? Now, yeah. We're going to go ahead and put in our -3 and our x minus 3. That's one portion. So we get something from that fraction, plus we get that extra 1. Why? Because, dude, that's the constant. We just get, everyone gets 1. Isn't that nice? Yeah. It's like, yay.
You get a free toast.
Okay? All plus 1.
Are you Oprah?
What goes right here?
3.
What's our vertical?
3.
3. And that is?
Undefined.
Undefined. So even though this one gets the 1, it doesn't matter. Sorry, man. Okay, it's undefined. Okay, why? Because we have the undefined part out front. When we put 3 in for this, we get an undefined. We get a 0 on the bottom. That's bad. Okay, now remember last problem, what did we do from there? Yeah.
We tried to make it so that it evens out, and I can't words.
We tried to multiply x by y to get the top, right?
Yeah.
Okay, remember we're saying y equals -3 over x was our last problem, but now we have this -3 in there. So we're taking x and subtracting 3 from it. And the way we handle that, and the way I handle it, okay, I like to think of this as, hey, I'm taking x and multiplying it by y to make -3 still. What happened to this -3? Well, we're going to deal with that at the very end. Since they're subtracting 3 up here, we're going to satisfy that by doing the opposite, which at the end we're going to add 3 back on to whatever value we come up with. Okay? Everyone see how we're handling that? Okay, so give me some things. Let's start with negatives that multiply to make 3. -3. -3, 1. Okay? What else? -1, 3.
0.5 negative 2. I mean, 1.15. 1. I'm not talking about 1.5.
I know what you're saying, but I'm going to stay with just whole numbers for now. Okay? 1 and -3. I guess we're dealing with integers, so we're not using whole numbers with the negatives. But okay, and this one is?
3 and -3.
3 and -1. How many are good on that?
Yeah, man.
Okay. Don't let the -3 confuse you yet. Question?
Aren't like the top and the bottom the same thing?
This is an x. This is y. Yep. Okay? We're good? Now, to counteract this piece, we are going to add 3 back on. So rather than having -3, we're going to actually have -3 plus 3, which is 0. Oh, I put it in the wrong spot again. Unbelievable. I always do that. It's like some mental block. I'm going to put the 0 there. Sheesh. Good thing I'm using erasable pen. No, I'm not. But I wish I was. I thought if I thought about it, it would be the thought that counts, but it didn't work there. Okay? All right. So -3 plus 3 is 0. And when I put 0 in here, notice what I get. 0 minus 3 is? -3. -3 divided by 3 is? 1, that same 1. Guys with me? Okay. Negative 1 plus 3 is?
2.
Just 2, right?
Oh, negative.
And if I put 2 in here, what's 2 minus 3? Negative 1. 3 divided by negative 1 is?
3.
Dude, it's 3. It's that same piece. That's pretty righteous. Okay, what is 1 plus 3? 4. What if I put 4 in for x and put it there? What do I get? I get 1, and negative 3 divided by 1 is? Negative 3. Okay? So when I put 3 in, 3 plus 3 is? 6. Bless you. What do I get out? What's going to go here? That's going to be that negative 1, and you can test it, right? You can put that 6 in. 6 minus 3 is 3. Negative 3 divided by 3 is negative 1. Everyone understand how we deal with that negative 3 on the bottom? We just add 3, our shift. Okay? Now, if you're like, that stuff you're doing right there is just way too confusing. Like, I don't get it. Okay? If that's fine, that's fine. The other route to go is rather than doing any of this stuff right here, you could just kind of, let me find a piece of paper where I can just cover it up. It doesn't exist. Okay?
Where you go?
All you do then is you do the things on the back of the sheet you're graphing on right now. They're on the third step. I believe it's the third thing. It says, try to make what?
Denominator equal 1.
Try to make the denominator equal 1. So what values could I put in for x to make that 1? 4. Okay, negative 3 divided by? 4 minus 3 is? 1. Okay, that gives you this one. Okay? So there's a couple ways you can do it. On Monday, I'll walk through one going the other route. The route that's on the back of your sheet there. Okay? So, let's go ahead and finish this one up. We get what?
2.
2. 4.
2.
Negative 2. 0. So you order pair. 0, 2. 2, 4. All right, now really we should have 2 more points. What else could make negative 3, Eli?
1.5 and negative 2.
1.5 and negative 2. Okay, 1.5 we'd put over here. 1.5. That's going to give us negative 2. Negative 2 plus 1 is?
Oh, wait, don't you have to add 3?
Huh? Oh, I have to add 3. I forgot. Sorry, that would be 4.5. Shoo. Which means it should actually be down here. Unbelievable. But that's okay. It doesn't matter. Okay. What's 4.5 plus 1? 5.5. Okay. And what other?
Wouldn't it just be 2? Negative 2 plus 1? Because it's like still.
Negative 2 plus 1, yeah.
It's not 5.5.
Oh, that would be, yeah, my gosh. That would be negative 1. Unbelievable. Holy moly. I know, that's what happens when we get in a rush. Okay.
X minus 4.5 minus 3.
That's right.
Is 1.5. Oh, wait, negative 2.
Okay, what could we put here? Yeah, so the other combination would be negative 2 and 1.5. Okay, and if we add negative 2 for x and add 3, that's 1. 1, that's going to give us 1.5. And 1.5 plus 1 is 2.5. So we have 1, 2.5. And then we'd have to plot the points and graph them. Okay, your assignment tonight Go ahead and take a look at the example side of your paper. Your assignment tonight is to complete number 4 and then do number 5 and number 7. 4, 5, and 7. So finish this one, and then you have to do 2 more, and I want you to try this method. Okay? Do not cheat using your calculator. If you are a calculator cheater, you will pay for it later. I promise you. Okay? All right.
That feels like a hint.
Very good.
I'm not a calculator cheater. I'm just lazy.
Go at it.